When a developer finds a list of free APIs, it feels like discovering an open road for their project. But treating these community-curated endpoints as production-grade infrastructure introduces unacceptable instability into AI and data pipelines. The difference between a learning exercise and a reliable system comes down to one missing guarantee: the service level agreement. Today, we connect that headline to the engineering trade-offs behind the hype, revealing why relying on free resources is often a silent failure pattern for serious applications. The illusion of stability begins with how these lists are consumed. Publicly curated repositories like public APIs are frequently treated as free infrastructure, yet they lack the fundamental engineering guarantees that production systems require. There are no uptime contracts, no dedicated support channels, and absolutely no accountability when things break. Unlike a server crash that throws an immediate error code, free APIs frequently suffer from silent degradation. They return stale data, inject advertisements directly into JSON responses meant for your application logic, or silently drop connections mid-scrape without warning headers. This behavior turns every integration task into a fragile system design nightmare, where the engineer must build complex fallback logic and retry mechanisms just to handle what should be basic connectivity issues. Consider the statistical reality of these resources. In empirical testing samples of 10 random free proxy IPs from such pools, only one was usable for a sustained period. 4 were completely dead, 3 timed out repeatedly, and 2 injected ads or stripped necessary headers entirely. The half-life of a working IP in these shared environments is measured in hours rather than months due to high-density usage by unknown actors engaging in credential stuffing or spamming. Furthermore, security risks are inherent. Operators often log sensitive user data, including cookies and form submissions, creating compliance vulnerabilities for any application processing personally identifiable information. This creates an environment where the cost of instability far exceeds the price of a reliable paid alternative when you factor in developer hours spent firefighting broken endpoints. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The volatility of these resources is not accidental. It is often a deliberate design choice within the open-source ecosystem. A field study analyzing 400 popular Java libraries found that developers intentionally introduce breaking changes to simplify interfaces or add new features, with no backward compatibility guarantees provided to consumers. In just 4 months alone, researchers identified 59 confirmed instances where APIs were broken across 19 different projects. This confirms that relying on a community-maintained list is effectively building on sand. The endpoint you integrated today may be deprecated tomorrow without notice. For AI and data engineering teams, this means treating stochastic environments as deterministic sources of truth leads to suboptimal costs in terms of wasted compute cycles on failed jobs and downstream model degradation due to missing or corrupted training batches. Even when an API works initially during development, it often collapses under production load due to arbitrary caps imposed by maintainers trying to manage their own infrastructure costs without revenue. The Tracked API case study demonstrates this clearly. A maintainer introduced strict new limits and HTTP status codes after applications began creating lists with over 100,000 items. Non-VIP users were suddenly capped at 5 personal lists of only 500 items each, effectively breaking any application designed for scale without prior warning or SLA protection. This forces engineers to rewrite logic overnight because the assumption that free means stable is fundamentally flawed in a production context where growth triggers failure modes rather than success. The cost of deterministic planning in stochastic environments becomes apparent when we look at how these failures impact project timelines and reliability engineering. Research into production planning shows that ignoring forecast errors leads to severe penalties regarding capacity, backorders, and inventory management. In the context of AI data pipelines, treating a free API as a stable source creates similar inefficiencies where failed jobs waste expensive GPU cycles on retries rather than training models or running inference queries. The average reduction in project completion times following proper API implementation is 20%, yet teams relying on unstable free resources spend that time rebuilding infrastructure instead of innovating features. The engineering judgment shifts when we apply the specific criteria for safety. Does this endpoint have a service-level agreement? Is there authentication enforcement with clear rate limits? Are those limits transparent and stable over time? If not, the decision matrix points immediately toward paid alternatives or in-house data collection strategies that provide ownership of the infrastructure. Engineers who treat these lists as production-grade assets are building systems that will inevitably fail under load, leading to constant firefighting rather than strategic engineering work. The trade-off is clear. You can save money on licensing fees today by using a free list, but you pay for it in lost time and compromised reliability tomorrow when the service vanishes or changes its rules without warning. The verdict comes down to knowing your context. Free APIs are excellent resources for prototyping, learning frameworks, or testing local logic where downtime does not impact real users. However, using them as critical infrastructure for AI training, financial data ingestion, or any production system that requires high availability is a trap. The stability of the downstream application depends on the upstream guarantees you can actually enforce, and community lists offer none. By recognizing this failure pattern early, engineers can stop building fragile systems and start designing robust pipelines that survive real-world demand without constant intervention. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.